Hello, my dear students. Today we are here to deliver another lecture in electrostatic series, chapter 1 of basically unit 1 of 12th class physics. And in this, we have already done in the last lecture that what is Coulomb's law in electrostatics. Today we will see that Coulomb law in electrostatic can be written in vector form also. What is vector? You have already studied in 11th class. And don't worry, if you don't know anything about vectors, I will tell you wherever it is necessary so that you can understand this topic. Right, so today's topic is vector form of Coulomb's law in electrostatics. What is Coulomb's law of vector form? Let us consider two charges, say Q1 and Q2. Right? These charges are r meter apart. We already told you. These are the point charges. Let me define again and again that these are point charges because Coulomb law is applicable to point charges. And what is a point charge? Point charge means the dimension, the linear length of the point charge is such that it is very smaller than its distance between the two charges. If the distance between the two charges are very, very far, these charges can be taken as point charges. So we have 2 point charges Q1 and Q2, and these charges are separated by distance r. Now, if this is a positive charge, this is a positive charge. What will be there? Electrostatic repulsion or electrostatic attraction. Naturally, these are same charges, like charges, so they will repel each other. It means Q2 will exert force on Q1. Let the force exerted by Q2 on Q1 is F12. It's simple notation like F12 mean force on 1 mean Q1 due to 2 mean Q2. Similarly, Q1 will also exert force on Q2. It will put a pressure on this charge so that there is repulsion. It will go away. So this force is say F21. Mean force on 2 mean Q2 by force by charge number 1 mean Q1. Okay. So what is F12? Force on 1 mean Q1 due to charge number 2 mean Q2. What is F21? Force on 2 mean Q2 due to charge Q1. This exerts force on this and this exerts force on this. Right? So let us suppose the unit vector. Now what is unit vector? You know what is a vector. Let us say this A is a vector. Vector mean, what is a vector? You already know. Vector means a pointer which shows the direction basically. Okay, so if A is a vector, then this A vector divided by its magnitude is called as unit vector of A. So unit vector of every vector is a vector. This is a unit vector denoted by cap. If you put cap on some letter, it is called as unit vector. Unit vector is unit mean 1. So unit vector is 1 whose magnitude is unity. So if we take its magnitude, it will be equal to 1. And its direction is same that as that of the vector. So what is the need of unit vector? Actually, unit vector gives the direction of the given vector. To specify the direction, because you know what are vector quantities? Magnitude as well as vector. Like force is a vector quantity. Okay. So if we have taken this arrow mark on this to show it as a vector. So to show the direction of the given vector, we take a unit vector associated with that. Its magnitude is unity because so when something is multiplied by unity, is there any difference? No. So this magnitude is unity, but the direction is same as that of the given vector. That's why it is called a unit vector. But it gives the direction only. Always remember it gives direction of the given vector. So here also, naturally, this r, what is r? Distance between these two, if we take it as a scalar quantity. But if we have to convert it into vector form, then everything will have to be converted into vector form except charges, because charges are always scalar. Remember, charges are always scalar, but force, vector, that's why shown in vector. Now what is left? If you remember the formula, in the last lecture, F equals to Q1 Q2 upon R square. So now we have to take R as a vector. So let us suppose the unit vector from 1 to 2 is R12, R12, and the direction will be this one. Mean from 1 to 2, and here it will be R21. We take cap because it is a unit vector. So what is R21? From 2 to 1. This is R21. So this is nothing but, what is this? Unit vector from 1 to 2, Q1 to Q2. And what is this? Unit vector from Q2 to Q1. Okay. So if we take F21, what will be value according to Coulomb's law? 1 by 4 pi epsilon 0 Q1 Q2 upon R square. This is okay. But now we have to convert it into vector form. So we'll put vector here. What will be the vector? R12. F. Because what is F21? Force on 2 due to 1. Mean 1 is exerting force in this direction. If it is exerting force in this direction, here we will take vector in this direction, and vector in this direction is R12, 1 to 2. Right? That's why I taken R12. Equation number 1. Similarly, we can write F12. What is F12? Force on 1 due to 2. It will be equal to 1 by 4 pi epsilon 0 according to Coulomb's law. Q1 Q2 upon R square. Now here we have taken R12. Here we will take R2 and why? Why? Let me explain you this thing. R21 is taken. Why? F12 mean force on 1 due to 2, mean in this direction. Force on 1 due to 2. This Q2 is exerting force here. So the vector R will be from 2 to 1. 2 to 1, like in this direction. Okay. That's why I taken 2, 1. So this is equation number 2. Now these are the vector forms of Coulomb's law. That's final. But what are the results which we get from it? Look at this. You know that R12 is equal to minus R21. Just see. This vector is in this direction, this vector is in this direction, so they are opposite to each other. That's why we put negative sign. You have learned in vector. This can be written. So means if this vector is A and this vector is A dash, we can write A equals to minus A dash. You know that. So if directions are opposite. So R12 equal to minus R21 cap. If you put this value here and here, these are same. 1 by 4 pi epsilon 0 same. Q1 Q2 by R square same. So by using these values here, what do we get? F12 equals to F21. Very important result we get, and with negative sign. Always remember, because here it is negative. We'll put R12 equals to minus R21. So minus R21 mean R21 cancelled. This all cancel. F21 equal to minus F12. So F12 equal to minus F21. What does this show? That force on 1 due to 2. That force on 1 due to 2. The force which is exerted by Q2 on Q1 is equal to the force exerted by Q1 on Q2, but opposite in sign. What does this show? Do you understand something? This is Newton's third law of motion. What does Newton's third law of motion say? For every action, there is equal and opposite reaction. So if Q1 exerts force on Q2, then Q2 will exert same force on Q1, same force, but in opposite direction. That's why taken negative. So this thing states that Coulomb's law always follow, Coulomb's law in electrostatics always follow Newton's third law of motion. And what does Newton's third law of motion says? For every action, there is equal and opposite reaction. Just see. Force F12 means force on 1 due to 2 is equal to force on 2 due to 1. They are equal, but opposite sign, negative sign shows that equal and opposite reaction. This is action, this is reaction, but opposite. Due to negative, it is opposite. So always remember, Coulomb's law in electrostatics follows Newton's third law of motion. That's a simple concept, isn't it? So what another information we can get from this? Is there any another information which we can get from this? What does this law states us? One thing we have already done, that Coulomb's law in electrostatic obeys Newton's third law of motion. What is the other thing? You know that this is charge Q1, this is charge Q2. The force is along the line, just see, due to this joining Q1 and Q2. Any force whose direction is along the line joining the two quantities is called as central force. Okay? You have heard this thing. So here Q1 and Q2 are such that the force between them is along this line only. Like Q1 is exerting force on this and Q2 is exerting force on this. So force is along the direction of the force between these two is along the line joining these charges. Hence, the Coulomb's law also gives us idea that these charges are under central force. So the force of attraction or force of repulsion is an example of central force. What is central force? Central force is one between any two bodies, is the force which directs along or whose direction is along the line joining the two bodies. So another example of central force may be gravitational force. If you remember, in gravitational force, we have two bodies, and the force of attraction between them is given by F equal to gm1 m2 upon r square. So that force is also central force because that is also along the line joining these two bodies. So we get two inferences, two results from Coulomb's law. Number one, that Coulomb's law in electrostatic follows Newton's third law of motion. And number two, the forces between these two charges, that is electrostatic forces and or repulsive forces between the two charges, are kind of central forces. Okay, our next lecture is limitations of Coulomb's law. In electrostatics. What are the limitations? You know, limitations mean that where this law do not hold good, where we cannot apply Coulomb's law in electrostatics. What are the cases? Number one, this law holds for charges at rest only. Always remember, charges must be at rest. Mean static charges. Static. Okay. So Coulomb's law of electrostatic repulsion or attraction, Coulomb's law in electrostatics, holds good only and applies only when the charges are at rest. First condition. Second condition, that the charges should be point charges. Charges must be point charges. What is the meaning of point charge? Point charge means that linear dimension of the charge is very, very smaller if we compare with the distance between them. Okay, the distance between them is too large, so the charges will be considered as point charges. So the third condition which Coulomb's law in electrostatic have to follow is that, you know, what is the size of atom? This is atom. Size of atom is 10 to the power minus 10 meter. And size of nucleus is 10 to the power minus 15 meter. Right? Always remember. Size of nucleus. Nucleus is small, that is inside the atom. Atom is bigger than nucleus. Okay. So the size of nucleus is 10 to power minus 15 meter. So the condition is Coulomb's law will hold good if two charges Q1 and Q2, the distance between them is greater than 10 to the power minus 15 meter. Okay. If the distance between two charges is less than 10 to the power minus 15 meter, the charges will lie inside nucleus. Simple means. And if they lie inside nucleus, there will be a nuclear force also. That nuclear force will dominate, will be more than, will impact in a great manner than the electrostatic force of attraction or repulsion. So, if we want that this law holds good, we can find the force between two charges using this law. Then the distance between the two charges must be greater than the size of nucleus, because everything is made up of atom and atoms have nucleus inside that. Okay, so if the distance between the nucleus is less than 10 to the power 15 meter, the charges will go inside the nucleus. And inside the nucleus, which force is dominant, predominant? Nuclear force. But we have to find electrostatic force. It will not be calculated, it will not be determined, because it will be very less as comparison to nuclear force. Even we will not be able to find it due to the constraints of the nucleus. Okay, so these three are the limitations of Coulomb's law in electrostatics. Thank you very much for your patience hearing. You are requested to please subscribe to my channel if you are a new viewer, and please share it with your friends so that they can also enjoy learning skills. Thank you.